Nexus PMG welcomes you to the Bigger Than Us podcast, which we as energy geeks lovingly refer to as the BTU. Bigger Than Us is a podcast that focuses on ideas that will shape the future of our planet and ultimately our existence. We will occasionally lean into energy topics because, after all, it's the key to our collective survival. But we'll also explore other ideas and topics that we believe will have an impact that is bigger than us. And now, on to today's show. Hello, and welcome to the Bigger Than Us podcast. I'm your host, Raj Daniels, and today I'd like to welcome Ryan Hunt to the show. Ryan Hunt has degrees in physics and bioengineering from the University of Georgia. Ryan has a passion for circular technologies, including algae, photosynthesis, and thermoplastic compounding. Ryan co-founded Algix that creates sustainable technologies for environmental restoration and biomaterials under the Bloom brand. His team collaborates with government and corporate partners for cleaning air and water pollution and transforming waste into consumer products. Ryan, how are you doing today?
Hi, Raj. Thank you for having me today.
Ryan, I'm very excited to dig into our conversation, and I'd like to start with, what is an eco-pioneer, or who is an eco-pioneer?
Well, it's a good question. It's people looking to push the boundaries of sustainability, trying to find value in waste and think about materials in a new way, and particularly materials that can provide environmental restoration purposes. So, with our company, we focus on algae. We think algae is an undervalued resource in the world. It's ubiquitous around the planet. And we want to see more companies doing more things using algae.
I appreciate you expanding on the definition. And since you mentioned algae, can you share with the audience or give the audience an overview of Algix and your role at the organization?
Yes. So I'm the co-founder and chief technology officer for Algix and our brand, Bloom Sustainable Materials. And for the past 11 years, we've been using algae as a tool for environmental restoration, where we clean water, capture carbon, and produce a renewable material that can be used as an ingredient in a wide range of consumer products. So we essentially use the algae in its natural form, and that algae is used to replace a percentage of petroleum-based or traditional plastics in finished products.
How do we end up with a finished product that can help replace some of those products?
So we produce pellets. Our business is really one of compounding. So our part of the value chain is to work with government agencies and utility companies to set up either environmental restoration projects or to set up environmental protection projects where we intercept the pollution, the emissions directly from the factories, such as wastewater treatment facilities or power plants. We also work with government agencies and contractors that are cleaning up wild algae blooms. So essentially lake cleanups or lake restoration that removes what's called eutrophication. And eutrophication is a fancy word for essentially water pollution. And with too much eutrophication, the water body can actually release methane and carbon dioxide, as opposed to being a sink for carbon dioxide. It can actually release greenhouse gases versus absorb them. So as the planet is increasing its levels of water pollution due to more human activities and not enough water treatment technologies in place, particularly in developing countries, the result is that a lot of our common freshwater resources are becoming significantly impacted by harmful algae blooms and other issues.
So recently, 2 episodes ago, I published a conversation that I had with a gentleman by the name of Dr. Rob Moyer, and he was doing a project down in Florida helping encourage lawn owners, so homeowners, to stop using certain pesticides and fertilizers because they were causing algae blooms in the waterways. Is that an environmental restoration project you would get involved with?
Yeah, in a roundabout way. So in that example, we had a project back before COVID where it was essentially funded by the U.S. Army Corps of Engineers because they are in a way responsible for discharging nutrient-laden water from Lake Okeechobee in Florida. And Lake Okeechobee has a variety of nutrient-rich inputs. There's farming, there's sewer systems, septic systems. There's maybe other industries that lead to nutrients building up in that water body. And there's two dams that release that nutrient-laden water to the coastlines. And so the canals and the coasts can be negatively impacted by this excess levels of nutrients. And some of that's coming from the collection on Lake Okeechobee. Some of it's coming from the communities and lawns and wastewater plants that are closer to the coast. But at the end of the day, we're battling a similar issue. It's phosphorus, it's nitrogen that's making its way into the water. It's creating the conditions for algae blooms, for photosynthesis to occur in the water column. And so with the Army Corps and our partners, AECOM, they actually deployed technology that we had developed on fish farms earlier on in our company's history when we were ourselves trying to figure out how to efficiently harvest algae out of freshwater bodies for our own supply chain. And so we developed a mobile platform that operated on catfish farms. So it was a 25-foot long, about 8-foot wide trailer, and it has a bunch of equipment on it that essentially uses air bubbles and a little bit of salt to coagulate the algae, which means they essentially, instead of it being like green Kool-Aid, they start to clump up, and you get, they settle out of solution, and they can be separated using micron-sized air bubbles that float them to the surface, and then you essentially skim off the thick algae paste into a collection vessel. So our units would run about 200 gallons per minute, maybe a little bit higher, a little bit lower, depending on the concentration, and that would allow us to harvest and clean over 250,000 gallons of water per day, typically. And so what we developed for these fish farms ended up being quite interesting for mobile restoration in canals and lakes, and as a demonstration tool. So we've done a lot of demonstrations for government agencies that are being faced with having to solve algae bloom problems, harmful algae bloom problems, particularly in drinking water reservoirs and tourism-rich areas, public areas. So we've done several projects over the years with AECOM, one of our customers, of course, being the U.S. Army Corps, but also other agencies as well in New York and in Florida. And we're hoping this grows. We really need to be able to deploy a rapid mitigation technique against areas that might have harmful algae blooms. But the scale of doing that is important, but if we can actually intercept the pollution before it's released into the water, it becomes a lot more efficient. And so our goal long term is not to keep the environment in some perpetual harmful algae bloom state just to have algae, but rather let's clean up the lakes, let's collect the algae and the nutrients and get it out of there as a near-term solution, or near-term restoration project where we can valorize that biomass that's coming from those sources in a way that helps support the project, but also find out where the nutrients coming from in the first place. And so let's work upstream and tackle the problem at the source as much as possible. It's not always possible, but where possible, let's try to cultivate algae in a more engineered way at utility facilities, at factories, at textile plants, at the water utilities themselves. And that gives them a new agricultural commodity that can be produced off their waste. So you'll see a lot of facilities installing anaerobic digestion for generating biogas and renewable energy. Or in this case, we're essentially taking that nutrients, the nitrogen and the phosphorus, and producing a biomass that can be sold as a dry product in a commercial market with relatively high value.
So I think you've just changed my perspective on the word nutrient. I always imagined a nutrient to be something positive and something you'd want more of. But if I'm understanding correctly, in this case, a nutrient is not a good thing. Is that correct?
Well, when we say nutrient, we're talking about plant nutrients, N, P, and K, nitrogen, phosphorus, and potassium, and carbon. CO2 is a critical nutrient, and they're essential for life. But in the problem that we have is that we generate a lot of fresh water that is contaminated with small amounts and trace amounts of ammonia and nitrates and phosphates. in carbonates and just infused with CO2 from higher concentrations of CO2 in the atmosphere. All of these things lead to accelerated phytoplankton growth and algae growth. And if you look at the planet as a whole, the phytoplankton or the algae around the planet, and there are 30,000 different species of algae. So it's not like it's just one thing. It's this massive class of ancient organisms that live in the soil. They live in lakes, they live in rivers and canals and estuaries and in the ocean. And they are responsible for over half of the oxygen produced on the planet, which makes them as, if not more, impactful than the rainforests. Yet, we talk a lot about how important it is to not cut down the rainforest and to conserve the rainforest and to try to regrow the rainforests. But we really don't know how to leverage this algae based capacity on the planet. And so there's been a lot of research going back to the 70s on viewing the exponential growth rate of algae as an opportunity to capture and utilize waste CO2 from the CO2 pipelines that are being built around the country, around the world, and power that sequestration with sunlight using photosynthesis. And as opposed to storing the carbon in the soil like we do with plants under regenerative processes, instead we're looking at capturing that carbon in the form of biomass and then converting that biomass into everyday products. And so we feel that this process is one that can be scaled and is really critical to the long-term survivability of and sustainability of the planet in terms of the materials that we extract from the planet and utilize to make everyday products that we love and require.
Now, how did you and your co-founder come up with the idea to harvest algae?
Well, in graduate school at the University of Georgia, I started with turning pine trees into green crude oil. So we were running pine trees and other agricultural waste products into a thermochemical conversion process called pyrolysis. And this essentially yielded a dark crude oil that smelled like a campfire. But it was my job to break it apart, analyze it, figure out what it was made out of using different analytical techniques, and really find out its value and how the processing impacted the quality of the oil. And it looked very much like crude oil, really. There's some issues that needed some purification and processing, but with scale, all those things seemed viable. So that was where I kind of got first introduced into this concept of treating plants as as oil or as a renewable resource and converting it. And so now you'll see. I think Shell just announced they're using Fischer-Tropsch to convert biomass into essentially jet fuel or fungible fuels. So those processes are there, but the big challenge has been all this algae is growing. These blooms are happening all around the world. There's this massive opportunity to utilize this organism, but it hasn't really happened yet. So the scale of the production, it's all very research level. It's academic. It's at universities. There's been, and I'd say in the 2007 when I first got involved, was kind of the first major reinvestment since the government research from the 70s and 80s. And so when that happened, there was big money. Bill Gates Foundation, Exxon Mobil, Shell, BP. There was over $1 billion invested into algae biofuels in the mid to late 2000s. And that was going pretty well until the price of oil collapsed with the fracking boom in the U.S. and a massive decrease in oil prices around 2014. That happened to coincide with the grand opening of our algae plastic facility, which almost killed us. We had built a business model around using polymers like polypropylene and polyethylene to make compounds, and all of a sudden, almost overnight, those prices dropped in half. And it wasn't like we had that much margin to begin with. Material businesses typically aren't high margin businesses. And it's all about volume. So very quickly, the margins went away, and the volume requirements are just massive. And so we almost, as a company, we almost failed right out of the gate. But we were fortunate. We hung on. We retooled a bit, and we brought in advanced manufacturing. We started making 3D printer filaments for a specialty market. So it was a higher value product going into high value, more innovation-oriented customers, and that landed our brand name, our materials, our story, our mission on the desks of innovators all over the world. We weren't particularly successful overall, but it was a step. It was a major step, and it also taught us as a scientist and in entrepreneurs. We built a manufacturing team, we built a marketing team, we built a sales team. We had products on Amazon. We had all the sourcing. We had a sourcing team, so we really built out this supply chain for getting algae out of these environmental restoration projects, getting it into our factory, and then allowing us to formulate the algae with a variety of different polymers that added value to our customers' products. And so with the 3D printing, you're not really doing mass production with that. This is kind of conceptual stuff. So we're dealing with the designers and the developers and just breaking their conception about what can be done with algae. Step phase 2 was a reformulation, but really focused on same concept, but delivering a pelletized product to innovators in the footwear space and essentially branded consumer products. These companies have sustainability initiatives. It was increasing. We got into it in 2015, 2016. We started reaching out to footwear brands. We started finding a lot of interest there. But then we realized the ultimate challenge, which is that they didn't actually really manufacture their products. They designed them, they spec them, but they didn't really make them. And the making all was occurring and is occurring in Asia. So it's China, Vietnam, Indonesia. And so us being in the US put us at a major disadvantage because there really wasn't any manufacturing happening in shoes here in the US. So we decided that to play in the footwear game, you've got to be able to introduce your product to the factories that are making the shoes. And that started in 2016, a huge effort that we call Bloom. Bloom has become our brand, and we built a trading company in China. We have warehouses in Vietnam, China, and here in the U.S. And we work with over 200 partner factories now that are essentially foam manufacturing factories and footwear manufacturing factories. So they're looking for sustainable materials, new innovative products that they can offer to their brands and to their customers and to the designers and developers. And so that has been a long and very challenging journey. But now we're in a position where the customer, the brands, if they want to use Bloom, it's not that hard to do. We have integrated our material into the global supply chain in a way that it's relatively easy to get your hands on, at least if you're a footwear brand. And now we've been expanding outside of that. We've been working with some other factories that make automotive parts or make yoga mats or make bicycle grips. So it's exciting now. Trying to really focus on footwear, but really fundamentally it's these branded consumer products that we see as being one of the most obvious opportunities for us as we scale up.
So are you harvesting and shipping overseas, or you're also doing harvesting overseas?
Yeah, so the algae is coming from a couple different places. It started in California with a utility company that was using algae in an innovative way, but in essentially raceway ponds. So imagine like a Talladega, speedway or an Indy 500 speedway, but instead of it being asphalt, it's algae. It's essentially a shallow pond with raceway paddle wheels that move the water at a certain speed, and the ponds are only about a foot deep, so they're really shallow. And that was their final stage of treatment, and they would on purpose create an algae bloom in these raceway ponds and harvest the algae out of that, and that provided this polishing, which really reduced the amount of phosphorus and nitrogen and carbon being released back into the environment. So that was our first. And that was being done at a decent scale. A couple million gallons of water per day was being run through that process. So we started there. We also started with another company called ClearAs that is developing and is installing industrial scale photobioreactors, which is a more advanced version of it. It's essentially a raceway tube, or it's a raceway pond in a tube. It's a greenhouse system that has racking and 3 or 4 inch clear glass or polymer tubes that run really dense algae laden water through them. And so the idea is to maximize the light absorption in a unit volume, and so you have a very small footprint facility producing a lot of algae. So in cases where it's cold, you've got very seasonality or or in cases where you don't have a lot of land, you really have a small footprint, you can't just build out acres and acres of open ponds. Then these enclosed systems make a lot of sense. They're more expensive, but you do get a high quality, high output product. But then in 2014, 2015, the word kind of got out on what we were doing with algae and making products with it, making materials with it. And we started getting approached by lots of Chinese investors and companies and just interest. And it was really bizarre because we weren't soliciting that. But what we found out was that there was a big algae problem in China. And it's not too far off what we're experiencing in Lake Erie and what we're experiencing in Lake Okeechobee. So it's just kind of that times two or that times three, which in algae terms is not that far away when you grow exponentially, right? So we're having similar problems in the U.S., but in China they've taken action. They've taken major action, and they've built out a network of large scale water treatment facilities. Basically a wastewater plant that would clean a small city or a small town is being bolted up to a lake, by the dozens, and they have floating systems, they have trailer mounted systems, and the goal is to essentially separate the algae from the lake, pull out the carbon, pull out the nitrogen, pull out the phosphorus as part of that biomass, and then also oxygenate the water as part of the harvesting process. And that's what they do is they pump, just like our process, they pump a bunch of air bubbles into the lake water in a reactor offside the lake, and it super saturates the water with oxygen. It pulls out the suspended algae particles, and thereby removes a lot of the 90% of the nutrient loading. And then the water is returned back through kind of a managed wetland area or pumped back into the lake. And so by doing that, they're reducing the nutrient load. And then, but they have all this algae, and they were landfilling it. They were spraying it on farmers' fields. They're burning it, turning it into charcoal. So they were trying a bunch of different things, but they saw the value in our approach because now it's going into to replace a highly refined and carbon intensive product like plastics, 1-to-1, in some cases, at least in our master batch, it's about half and half algae and polymer. Now finished products may be less, just depends on the performance and the color and all these other parameters. But so now we're in a situation where those facilities exist. They were already producing a lot of algae. It was going to waste. It was rotting. It was degrading. It was going in some cases, just washing right back into the water from neighboring agricultural fields. So by taking it and putting it into a durable product, that durable product can capture and sequester that carbon and nitrogen over a much longer period of time.
How durable is the end product compared to commercial plastic?
So if we blend the algae with a compostable resin like PLA or PBAT or there's many others, the algae accelerates the rate of compostability or biodegradation once it enters that environment. So it's not going to break down on the store shelf or in your closet or something like that. But it will break down if it's if the moisture's there, if it's warm. It's got to be over 115 degrees Fahrenheit. Typically, there's got to be a lot of microbes available, microbial activity. So in that situation, the algae is acting as a bit of a superfood to help degrade biodegradable materials faster and more complete. However, when we blend them with durable materials, the goal is kind of the opposite. It's just to actually lock up that nutrient or lock up that carbon, and in a way that hopefully you can get a longer sequestration period and use it to displace a carbon-intensive product. So by replacing the oil-based plastic, we're actually getting a major benefit in reducing the greenhouse gas emission of that product's life cycle.
It's very interesting. So we'll switch gears here. Earlier you mentioned your work with trees and converting them to fuel, but the crux of our conversation is the why behind what you do. What drew you to this sector of almost, the sustainability sector, and what keeps you going? What's your motivation?
Well, it started in fuels. I actually started making biodiesel in 2006. I had a friend that worked at the Chick-fil-A, and I got some free fryer oil and was like, all right, this is cool. We can actually make our own energy, make our own fuels. And I didn't even own a diesel vehicle, but I just thought it was fun to do. And so we made some, and that kind of got me going and got me into this renewable energy area. And for me, it was just this epiphany that, we only have so much resources on the planet, that are easily accessible. And, and a lot of these come with negative environmental consequences. And so we've got to be very careful how we use the resources on our planet. And so I saw algae early on when I was in college as this kind of untapped resource, this frontier of biomaterials. I mean, back then, soybeans was what everybody was talking about. We were going to be running our entire fleet of vehicles in the U.S. on corn and soybeans. And in 2007, I was really, I mean, even before that, but particularly in 2007, I remember I was following this little company, this little startup company out of California, that was promising to make this, high performance electric sports car. And I was like, man, if those guys are successful and they can actually produce this is going to change everything. And the challenge that I see with that is that it's going to really eliminate the need for us to be burning hydrocarbons in our engines to move people around, places. And of course, the company was Tesla, right? And so I've been a huge fan of this innovative, disruptive approach to the market, particularly around thinking about problems in terms of first principles. And so for me, algae was the ultimate first principle when it comes to biomass and comes to materials, because we need a source of raw materials. Electrification of vehicles is a huge step forward. We're not going to be burning and releasing CO2 through that, but oil is used in a lot more situations than just being used in engines and internal combustion engines. It's used in materials and polymers and specialty chemicals. And so I saw algae really, for me, I pivoted in my mind out of the work that we were doing at the university at the time, which was all biofuel centric, and really started thinking about, well, what type of algae is already out there in mass quantity? Like, what's the easiest algae to grow or to find? And what's that good for? Because what we found was that the algae that was easy to get typically didn't have any oil in it. And everybody was after the oil. And so the idea of growing algae for oil was limited by the fact that you had to either genetically modify the algae. And so it's a very biotech and high risk of proposition. And a lot of companies did that. I mean, there's still companies now, synthetic genomics, that's doing that. And but then the other approach is to cultivate algae in enclosed reactors. So you're micro farming it in photobioreactors, and that was very capital expensive. So maybe more doable, but also super expensive. Payoff was not easy. So neither one of those to me resonated with a lean, mean startup innovative approach. I needed something cheaper. And so when we looked at this algae that was being used to clean water from these wastewater treatment facilities, we would grow. I mean, we would put maybe 5 or 6 different species that we found naturally, either in the water itself or in the dirt behind our lab. Like, it was just, whatever grew the fastest was what we wanted. And the stuff that grows the fastest tended to have a lot of protein and tended to have a lot of minerals in it. And that led to a situation where we could use the material in thermoplastics, because proteins by definition are polymer chains of amino acids. So our process kind of reforms and reorganizes these natural, thermoplastic like materials, these proteins, in ways that we can get some rheological properties out of the biomass. So it's not just like we're adding a filler. It's not just a calcium carbonate rock that's being dispersed into a polymer. Rather, the algae is being converted into a polymeric-like state. I mean, it's not perfect. Trust me, it's not the best polymer ever. We get that, but at 10, 20, maybe even 30%, we've been able to meet the specifications of some of the highest running, performance midsoles and soles for running shoes of some of the top brands in the world. So, and then you look at the volume, you look at the impact that switching over 10, 20, 30% of an entire industry can create. It's enormous. It's really enormous.
Well, I've never heard anyone speak as passionately about algae as you have, and absolutely changed my view on algae. Earlier, you mentioned challenging journey. What's some of the most valuable lessons you've learned about yourself on your journey?
Oh, wow. Well, certainly you need perseverance and you need passion. You've got to be genuinely obsessed with making this work, or else you'll give up. I mean, we've been at it 11 years. that was just as a company. Before that, it was over 3 years in kind of educational academia, and it's really hard, especially when you're trying to start a company. But I would say that I'm encouraged now more than ever. We made it through some dark times. We made it through I feel like we're just now kind of crossing what they call as the chasm of death for startups, where the rubber meets the road. You've got to make sales. You've got to be able to pay the bills. It's it's not just you can't rely on grants and a good idea anymore. It has to be commercially viable. And for us, as complicated, as simple as our concept is, it has turned out to be a quite complicated business to execute, because there's a lot of factors. There's a lot of external pressures. We're competing against the Exxon Mobils of the world in a way, but we're also partnered with the Exxon Mobils in the world in a way. We rely on polymers to make the products. So as companies and big companies are making more sustainable polymers, that gives us an opportunity to blend algae with it, and to find ways to make the algae more functional and more compatible, and and displace more of the base polymer. The big advantage that I think we've seen in the way that we've done it is we've decided that we don't want to be just a commodity. At this point, maybe in the early days, that's kind of the thought process. Hey, we're going to make this thing, this widget, but to get the word out, to achieve the long-term mission and vision of raising awareness around circularity, around recycling, around algae and its potential, you need a voice, you need a face, you need a brand, you need that DNA out there where people can connect with what your purpose is and understand it across different market spaces. So that's the reason we created the Bloom Sustainable Material brand, is to help the brands rely on a third party technical component or ingredient in their product that's focused on sustainability. Over the years, there's Gore-Tex and Intel, and there's a lot of technical ingredients that are very performance or functionally oriented, but we didn't really see a sustainability oriented functional ingredient for a product. And so I think that's kind of what we're trying to pioneer here, is if you see the Bloom brand in a product, that company is working with the innovation teams and with the sustainable materials that are going to be essential for creating products that have a low environmental footprint and impact.
Well, you mentioned long term. Let's leap into the future. It's 2030. If Forbes or Business Week were to write a headline about Algix Bloom, what would you like it to read?
I would like to be remembered or seen. Our company needs to be seen as the up and coming sustainable material company. We can help big companies, we can help small companies make strategic and educated decisions to improve the life cycle impacts of their products in a methodological way. And so we can work with brands to calculate the improvements in their carbon footprint and how much water they've cleaned, what's the real impact, and help consumers understand that when brands are trying to improve their supply chain, it's not an easy thing to do, but we need to be purchasing products that lean and move towards that long-term objective. We're not going to solve everything, tomorrow. There's no silver bullet per se for sustainability, because it is such a diverse topic. But if we could help the industry, particularly around footwear, using shoes and consumer products as a mechanism of storytelling and infusing these concepts and practices of circularity and sustainability into everybody's lives in a way that they kind of understand, hopefully that will result in other startups, other companies, other industries, other recycling loops being established that can dramatically accelerate our adoption and movement into this future circular economy.
I agree with you. And my last question, and this could be professional or personal, but if you could share some advice, words of wisdom, or even perhaps recommendations with the audience, what would it be?
For us, it's been really important to have a committed team. We have a core team of people. We're not a big company. We're a small company. We've had some growth and we've had some contractions over the years, but being able to rely on your team to execute and to innovate and I guess the other part that we've struggled with is on the commercial side, the brand building side. So if you're a company out there that's trying to bring a new sustainable material to market, it's not easy, and it takes a long time, and there's lots of constraints because it's typically a volume-based business. There's a lot of scale-up constraints. And so I would recommend, which is what we tried to do, was really leverage the customers, identify that problem in the market, the brand or the company that seems to be the best fit for you, and try to work with them. Really go do stuff at cost. Like, you really want their feedback. You really want to understand if your technology is a fit for them. And so whether that's applying for there's incubator accelerator programs that are maybe eligible for, that can help bring you into a new industry. Like, we've participated in some of those, both kind of generic accelerators as well as some very brand and company specific accelerators. I've seen a lot more of that recently, and we've had a lot of interest and a lot of success with those. Just being able to really understand what the customer is looking for, and get those connections with the right people in the organization to evaluate it and to hopefully be your champion to get it in and get into the market.
Ryan, I appreciate you sharing that, and I look forward to watching the continued growth of Bloom and catching up with you again soon.
All right. Thank you, Raj. It's been a pleasure. Thank you for asking these questions. Very interesting.
Appreciate it. Thank you for listening. If you like our show, please give us a rating and review on iTunes. And you can show your support by sharing our show with a friend or reach out to us on social media, where you'll find us under our Nexus PMG handle. If there's a subject or topic you'd like to hear about, send me an email, btu@nexuspmg.com, or contact me via our website, nexuspmg.com. And while you're there, you can sign up for our monthly newsletter, where we share what we're reading and thinking about in the clean tech, green tech sectors. Bigger Than Us is a Nexus PMG production.